What's going on? So this is a handy script that I use occasionally. I can demonstrate using these little these synth notes that I quickly mocked up. So this is what it's like all panned in the center. Cool. And then what the script is going to do is it's going to randomize the pans, but in a way that will maintain some semblance of balance between left and right. So there we go. That's put them in different places. Cool, try again. That last one was pretty evenly balanced. But yeah, that's the idea. Being able to quickly jump between different pan options. All right. There we go. Let's get into it. So we start by deleting the demo. And we're going to make our own one. So new action, new Reaper script in your folder. Pan, track pan randomize. I spell randomize the Australian way with an S, and you should too. All right. Cool. So we're going to wrap everything in a main function. Main without the B at the end. And we call it at the bottom. All right, so what are we gonna do? Like a lot of our scripts, we count the selected tracks, because what we want to do is we only want the selected tracks to be manipulated by this. We don't want to do it for all. So count the selected tracks. If no tracks are selected, then don't proceed. Cool. So assuming you have some selected, yeah, so iterate through the selected tracks. And so that's one of our for loops that we've done quite a few times now. Iterate through. Okay, so how we're gonna make this work is, and maybe you could think of a different way to do this, one that facilitates more randomness, but what I've done is every even track will get a value, and then the next one, which will be an even track, every even track will get a value, and then every next one, which will be an odd value, will get the equal and opposite one. So that's why they sort of end up doing this sort of thing all the way along. And the reason why I do that is then you maintain like a fairly balanced spread. Obviously, it depends on the volume of the track and the volume of the item, but generally speaking, it ends up reasonably balanced, because if it's like random all the way through, you could end up like all over the right side and that sort of thing. So that's how I've sort of decided to do it, and you get, good randomness out of it, even though it's every second one is randomized, if that makes sense. All right. So if the track is even, including index 0, that's why I start with even, because the first one will be even in terms of how Reaper indexes things. If the track is even, get a random pan value. Else, if the track is odd, do the opposite of the previous track pan. Okay, so that's how you end up with that sort of thing going on. And then set the pan on the track. And that should be pretty much it. So fairly straightforward, but I suppose the tricky part is these two steps. Cool. So let's get into it. So count the selected tracks. Count selected tracks here. All right, so num of selected tracks. We need a reference to the active proj. There we go. All right, so we do our check like we do in a lot of these scripts. So we only proceed if that is greater than 0. And this end finishes this if statement. Okay, so now for I equals 0 until, it's a very loud plane. So iterate through, starting from index 0, because that's how Reaper indexes these things. Number 1 is 0. So then like the last one you have selected will actually be the quantity of selected minus 1, because we started counting at 0. I've talked about this in a few videos now. So iterate through the tracks. Let's jump down here for now just to see what we're working with. This took me a while to find last time. Something to the effect of set media track something. Set track. One of the things I searched for was dpan, because it's one of those functions that you pass in one of the string parm names, parameter names, and it was dpan. So if we just go through the dpan functions, we should, sorry, if I keep searching through the dpan, we'll find it. We want like the set media, I've forgotten how to speak English. Here we go. Doesn't matter because I found it. So this is it, set media track info value. And we're going to set the dpan value. Cool. There we go. And we need that dpan, because that is the string that we pass in here. Go, and we do it on the track. All right, so we're gonna have to get a reference to the track. Get track. Get track. No, it was get selected track. That's the one. And we know that's the one because we're talking about the selected items, not all tracks, not all, yeah. So that's why we use that one. Cool. So we're storing a reference to that track called track, and we need to pass in the active proj. And then the index is going to be whatever the iterator value is, whatever the I value is at that point. So there we go. So we got a reference to the track, and then we're going to use it down here when we're setting information on that track. All right, so far so good. So let me demonstrate something. Well, first of all, we don't need a return value, so we can get rid of that. That was just like a success or failure value, I believe. Let's for now, yeah, we're going to have a new value. Let's for now, I just want to demonstrate how the numbers work. So if what this is going to do is it's going to set every selected track to have a pan value of 1. Now you can see my pans there. So if I run it, you can see that they're all 100% right now. If I do -1, 100% left. If I do 0.5, that's 50 right. Negative 0.5 is 50 left. And 0, lucky last, is center. So yeah, that's how the values work. And it actually says that, oh no, we've lost it. But yeah, if you go to this function, I think it says that in the notes. Dpan, yeah, -1 to 1. That's what that means. Those are the values. So it's not negative 100 to 100, it's negative 1 to 1. That's how this stuff works. All right. Cool. So maybe we'll do this stuff in a function. So I think we've done that in a recent video. I like to do calculation sort of things in functions. You don't have to, of course, but I find it neat and readable to do it that way. So get new pan value can be our function name. And we're going to pass in I as an argument because, you know, reading our notes, our design notes, if you will, it's very much dependent on what I is, whether it's odd or even or 0. So yeah, we need to feed that information into the function. All right, so let's copy our notes down here because this is where we're actually going to do them. So how do we do this? So if the track is even or 0, is 0 an even number? I'm not sure. Let's just say even or 0, then we get a new value. But if it is odd, then do the opposite of the previous track. So we're going to have to somehow keep track of what the previous value was. Okay, so we've done that sort of thing before, and the key to that is defining a variable outside of the scope of the for loop. So maybe not up there. We could have done it where I was just then, but maybe this is a better spot. So previous track value, and we'll call it nil to begin with because there is no previous track value. Or I suppose you could do 0 for the first one. Yeah, whatever. It shouldn't matter. We won't use this until we've stored a value anyway. But whatever. Let's call it 0 to begin with. Cool. And each time we do a new value, a new pan, we're going to store that pan on here. So it'll be like a running reference to our previous value. Okay, so that's how we're going to use that. Now, the way to check if a track is even or not, the modulo operation. So what modulo is it divides it by that number and then gives you the remainder. Okay, so you know, what we're doing here, if I modulo 2 equals 0, so what we're doing here is if you divide I by 2 and if the remainder is 0, okay, so if I is 6, 6 divided by 2 is 3, exactly 3 with no remainders. So I modulo 2 will be 0. Okay. However, if I is 7, you divide 7 by 2, you get 3 and 1 remainder. Okay. So if I was 7, I modulo 2 would equal 1. Okay. Meaning I is even or 0. Else if I modulo 2 equals 1 means I is odd. Okay, so another example is if I equals 3 at this point, how many 2's in 3? There's 1 2 with one remainder. So if this was 3, I modulo 2 would be equal to 1. So it's sort of like, it's very much like primary school maths. Like you divide it by a number and how many are left over. How many of this number goes into I, and then how many are left over. Yeah. Hopefully that sort of makes sense. But yeah, this is how we check for even and odd. And actually we don't need to do that whole thing. I just wrote that out as an example. Because what we can do is just else. Because if it's not even or 0, then it's definitely odd. So we can just do else. But I'll leave that there for your notes, in case you hadn't seen that before. Okay, so if we're here, then we want to do the random value. But if we're here, we just want to do, what we want to do is we want to do the negative of the previous value. So that's an easy one. So we define our variable up front, but then we're going to give it some values. So if we're an odd value, then we're just going to do the negative of our previous track value. So that's an easy one. However, when the case that it is even, this is where we do, some more complex stuff. All right, so what's the best way to do this? So we want to end up with a random value between -1 and 1. Okay. Now, we're going to do it in a few different steps. So get a random integer between 1 and 100. Scale the integer to 200. Scale down. This seems overly complicated. I can't remember why I chose to do it that way to begin with. No, I don't think we need to do it that way. That's, I think we can just do this. And then scale down to -1 and 1. Yeah, I think that's sufficient. I don't know what I was thinking just before. Oh, good. Okay, so we start off by doing math.random -100 to 100. Okay, so that's going to pick a random integer, a random whole number between -100 and 100. And then we need to scale that down to -1 to 1. So we do that by just overriding with pan divided by 100. And that's going to bring that into that range of -1 to 1. Cool. And then I think that's all we need to do. And then we can return the pan. Oh no, one thing we have to do is we have to store this value as previous track value. So previous track value will be pan each time we run it. And then we return pan, because remember, you can have a function that gives you an answer to a set of instructions. And that's what we're going to do here. So yeah, what we're doing here is new value equals, we'll do local new value equals whatever the outcome of this function is going to be. All right, now we need to select some tracks. Let's see how this goes. Nice. So 66 and minus 66, 63, 63, 24, 24, 2, 2. Cool. Let's run it again. Nice. I guess we could be listening to these things, right? Ah, you can't see the pans, sorry. Ah. Here we go. Ah. Cool. Didn't sound very different. Oh, that sounded different. That one had a nice sort of movement. Yeah, cool. So there you go. So let's just quickly review what we did, because there's a few steps. So provided that we have selected tracks, get a reference to the track, and then calculate a new value for the pan. So that's down here in this function. So if we're looking at an even or an odd, an even or a track 0, then we do the calculation. But if we're looking at an odd indexed track, it's just whatever the previous value was, the negative of that, the inverse of that. So yeah, maybe I should explain this. If previous track value was -1, then this one will be +1, because if you do minus minus 1, that's the same as +1. Not everyone knows that. Minus minus 1 is +1. So this is just the inverse of whatever the previous value was. However, if we're 0 or even, then we do it like this. Now, just a quick note: the reason why we didn't do just like this is because I think this could only be 3 values: -1, 0, and 1. Let's just see if I'm right about that. So select the tracks. You can see the pan knobs. Yeah, there. So they're all, we now have like a LCR panning. You know, maybe that's the type of script that Chris Lord-Alge would use, because he's known for his strict LCR panning. But for sound design, we probably want something a little bit more versatile, like that. Yeah. So that's the reason why we do it like this. This will give you integer values. So a way of getting like random values between -1 and 1 is to do integer values and then scale them down. So these random values will be random to 2 decimal points, right? So you could get like slightly more, I was going to say you could get more random values by doing, you know, -1,000 to 1,000 and then dividing by 1,000. But I think, you know, these pan values are only 0 to 100 anyway, so I don't think you get any more accuracy out of that. I think that'll have the exact same behavior as it was. Well, it's hard to tell if the behavior is the same because there's an element of randomness involved. But yeah, cool. Hopefully it makes sense why we're doing it like this. Cool. And I guess the last thing to do would be to give it a shortcut. So mine's going to be this. So then if I want to randomize just these. Yep, cool, that's good. Now I want to randomize these. And there we go. You can see that it's, yeah. opens up a lot of creativity, especially when you got a lot of layered sounds that you're sort of making a cacophony out of. Cool. So hopefully you found that useful, and I'll see you in the next one.